On this next page of notes, we're going to look into systems of three variables. We need to understand that the graph of an equation in three variables is a plane. When you think back to geometry, that should make sense because we named our planes with three letters, and we understood from geometry that 3 points are what it takes to determine a plane. We also need to understand what it means when we're solving our system of our three variables. The intersection of three planes can be a point, a line, or no solution. If you don't have the advantage of the textbook that I'm about to show you and you're trying to visualize this, you can think of the intersection of three planes being a point by simply looking at the corner of the room you're sitting in. If you look at the corner of your room, what you will see is that where the two walls in the ceiling intersect makes that single point. The three planes could intersect in a line, and we can imagine that line thinking about the wall in the ceiling and potentially another plane cutting through and creating that line or that crease all along the ceiling line. And then of course we could have no solution, and if you think about 3 floors in a building, those 3 floors would be parallel and would never intersect. In your textbook, they provide some pictures as well. Here we can see the 3 planes coming together at a single point, which they say is a consistent solution. You can see the 3 planes creating this line that would have an infinite number of points of intersection, and they also say it's consistent. Lastly, or they could be the same plane. And lastly, we can see this idea that the 3 do not have anything in common, or this was the idea that I referenced a moment ago about the 3 floors in a building. This would be an inconsistent solution when there are no common points between all 3. So when we're working through our systems of equations, we understand that one solution would have 1 point. We say it's consistent, and that point will be written as an x, y, z, or in whatever alphabetical order your variables are, and we call it an order triple. Infinite solutions would have an infinite number of points. Because it has something, we still say it's consistent. And when you're working those equations, all the variables will disappear. They'll all drop out, so to speak, but you will end up with a statement that's always true. So for example, 5 equals 5. No solution means that there are no points in common. We call that an inconsistent system. And again, the variables would drop out, but this time you would get a statement that's never true. For example, 5 equals 0. Our methods of solving will be the same as what we did for our systems of 2 variables, substitution and elimination. So on this page, we also want to look at the idea of just if you were working algebraically, what would this mean? If you were working algebraically and you ended up with the statement 3 equals 7, we understand that that's never true, so it's no solution. If you are able to get a distinct value for each variable, we call that the single point. And again, if you just get 2 numbers that are equal to each other and always equal, then we would say infinite solutions. So on the next page, we can look at what does that look like algebraically. This will also lead us into our ideas of how to solve. So when I have these 3 equations, what I can do is, again, just like before, I'm going to choose a variable to eliminate. And it doesn't matter whether I choose to eliminate x, y, or z. I just need to choose which variable I want to eliminate. So when I look at this equation, the first thing that I decide is I'm going to choose to eliminate x. It's important to use all 3 equations. So what I'm going to do is I'm going to compare these first 2 equations and thinking, how could I eliminate x? What I know is that both 6 and 9 go into 18. So if I multiply this first equation, everything in the first equation by 3, and I multiply everything in the second equation by a -2, I could eliminate x. So as you can see, I've given myself some notation of what math I'm trying to do. I'm going to take 3 times equation A, -2 times equation B. When I distribute my 3 to my first equation, this is my resulting equation. When I take a negative 2 and distribute it to everything in equation B, this is my resulting equation. Again, I simply add, because elimination method is often called the addition method. What I can see is all of my variables are going to drop out, and I get 0 equals 12. Well, we know that that doesn't make any sense, so we would say no solution, because our statement is never true. On my next example, again, I want to choose a variable to eliminate. And again, on this particular problem, it doesn't matter what I choose. So I'm going to choose to eliminate x again. I know that 6 and 4 both divide into 12. So I'm going to take 3 times the entire first equation and a negative 2 times my entire equation B. When I distribute my 3, this is my resulting equation. When I distribute negative 2 to equation B, this is my resulting equation. Add them together, and we get 0 equals 0, that we understand is always true, thus an infinite number of solutions.